So let's go over some groundwater fundamentals. This is bare bones. If you want a deeper discussion, there's an online site with free material called the Groundwater Project. It's gw-project.org. I also have a book that's I co-authored on that, going over the basics of groundwater hydraulics. So that could be helpful for you. So just going over some fundamentals here: aquifers and groundwater definitions, 3D oblique view of a groundwater system, also with the surface water body, reservoir, and a river. The voids in the soil of the rock beneath the surface, that part of the system that's filled with water is defined as the aquifer. And on the left there, I'm showing just a zoom in. Essentially, we've got, in this case, let's call this a sandy aquifer. Sand grains, in between those sand grains, it's saturated with water. If that water is reasonably extractable by wells, for example, then we call it an aquifer. And obviously, water in this aquifer is called groundwater. Okay, now we can break up the aquifer or the subsurface into at least three different systems, right? One of them is you have this aquifer and it's separated by a low permeability layer, which is referred to as an aquitard. So that essentially separates or hydraulically separates these two water-bearing zones, or the parts of the aquifer. And the portion of the aquifer above that confining unit or that aquitard is called an unconfined aquifer. That saturated zone beneath the aquitard is called a confined aquifer. Okay, so here just going over some basics. What's happening here? Where's the groundwater coming from? Well, it's coming from precipitation. The groundwater precipitates, it migrates downward, and it flows towards surface water bodies, which are at lower elevations in terms of water level elevations. So here are just some the fundamentals, some visuals. What's groundwater flow? Well, we've got Darcy's law, we've got hydraulics, but basically we're talking about saturated flow here. Take a look at this 3D perspective chunk of land here. We've installed some wells. In the wells, we encounter some water at the bottom in the screened interval. That is, there's a slotted pipe essentially through which water can enter. Typically, when we depict groundwater soil contamination scenarios, we'll use a cross section. So what I'm showing on the right here is kind of the equivalent cross section. I just kind of rotated that. And this is kind of the schematic we typically look at. So again, I've got the two wells and the water levels. And that essentially is equivalent to what we're seeing in this well. This is a very large borehole. This is not something you typically see, let's say in the US, wells used for irrigation or municipal water supply. This, I believe, is in sub-Saharan Africa. This is probably, I don't know, 2.5-foot diameter. But you can see here at the bottom, this water. That water corresponds to the water that you see at the bottom of this well. That water defines the top of this aquifer. And this line then is the water table. Now, the flow direction is based on the water level elevations. Here it's going from 50 to 49. Therefore, groundwater is flowing in this direction. Essentially, we're talking about hydraulics here, right? We're talking about water flowing from a place of higher potentiometric or higher potential energy to lower potential energy, just driven by gravity. Okay, and there are all kinds of ways to describe this, and it's different. It's different when you're in soils above the water table. The bottom line is the takeaway, I think, should be the groundwater flows in the direction defined by water levels in these monitoring wells. Okay, and when you have a lower water level, also called the hydraulic head, it's going to flow in that direction. Now, I've shown a really simplified case here. Generally, you need at least 3 points or 3 wells to define the flow direction. Nevertheless, this is gives you the fundamentals. Again, go to this website here if you want some more detailed information, get a better understanding, but a visual understanding of groundwater hydraulics.